Marco Codes! Hey folks, Marco here. Tell you what, I'm a bit bored with my Google Photos clone. Why is that? Well, because I can't see any of my pictures in the browser just yet and I want to be able to browse my albums. What does that mean for us? Well, so far we've been rendering thumbnails, but we haven't saved the fact that we did in a database table, for example, so that we can later on render an HTML page out of that table. Let's change that. And I'll tell you what, since this is still just a proof of concept, we're going to be using Java's plain JDBC API to do the database work. We're going to make it that simple, and along the way, we're going to cover the differences, the advantages and drawbacks to other libraries such as Hibernate, /JPA or Juke. So in short, you're going to learn a lot about database access with Java. Sounds good? Then let's go! Alright, where are we again? Well, we're still inside our app.java class, which is our Google Photos clone at the moment. And it consists of a main method where a user can specify a directory on program startup. And then we simply walk that directory, meaning all the files and all the subfolders. We try to find images, and for every image that we find, we try and create a thumbnail, right? That's it. Now, if the thumbnail creation process was successful, we increment a counter that we can, later on at the end display on the command line like, hey, 10 images converted to thumbnails. Additionally, what we now want to do is we actually want to save our image to a database table, right? So I'm just going to quickly create a skeleton method here, and we might have to change, the parameters here to that method and whatever. But first, we need to sort out a couple of other things. Let me share the thoughts in my head. Number one, the database access library we're going to be using. I already said at the beginning, this is a proof of concept, hence my tendency towards simplicity, and in that case also using Java's plain JDBC API. I don't want to immediately get the Hibernate hammer out of the closet and add endless complexity to my project. Later on, when we will convert the app.java class to a real, for example, Spring Boot project, this will look different. We're going to be using Hibernate, or maybe even rather Juke, which is a great library. Shout out to the creator of Juke, Lucas Eder. But for now, we're going to keep things simple. And as JDBC comes with the JDK, we don't have to do anything here. Add no libraries to the project. Number two, we need a database. Now, again, I want to keep things simple. I don't want you to have Docker installed and then, boot up a great database like Postgres or MySQL or whatever have you. Instead, I want to use an embedded database which suits this use case perfectly. Now, there's SQLite, I hope I pronounced that right, which is a great database, which we could be using, but we're in the Java world, and there's the H2 database, which is also an insanely good embedded database. Now, most people know the H2 database from testing, but in fact, for my Google Photos clone, it's actually a great database for production purposes also. And then later on, once the project gets much more complex, then we can think about, adding a real database to it. But for now, I just quickly go to my POM XML file because I need to add the correct dependency. And then I actually know what I'm looking for already. Which is why I'll just type com.h2. I know when I scroll down a tiny bit, this here, the H2 database engine is the library I need to add to my project. I click add, the library is here, and we're good to go. Database added to the project. Now that we have a database, there's just one final puzzle piece missing, which is a connection pool. Usually you don't have to worry about connection pools because they get pulled in, for example, by frameworks like Spring Boot automatically for you. But here we have to add our connection pool manually. And I have worked with Hikari CP a lot before, which is a great piece of software, a great connection pool. So I'll just try and add the dependency. I know the package because I have used it so often, so I'll just use, again, package search inside IntelliJ IDEA. The package is called Zaxa or Zaxa, whatever, however that is pronounced. And I know the first result here is my Hikari connection pool. Now, Hikari CP is added to the project, H2 is added to the project. We can write our schema.sql file. All right, so something that changed over the course of my career is that at the beginning I was relatively programming side / JVM side heavy, meaning that if I had an application that talks to a database, I would, start out with the Java classes, and then, let maybe, for example, Hibernate generate my SQL schema. At some point, once I learned more about databases, it kind of changed. And nowadays, I just want to make sure that I, handwrite my schema, and kind of think about what goes into the database. Now, I created a schema SQL file here inside my project. You can see two things in IntelliJ IDEA. It prompts me, hey, you haven't configured your SQL dialect, and I can simply change it to H2, and I get nice auto-completion features and error highlighting for this specific SQL dialect. So I don't even have to execute or run my queries against the database. I'll just, see the red error highlighting here. And also, I actually do, as a habit, once I write SQL statements, I want to see them work at least once against a test database, meaning we can configure DataSource here, /database, and I'm just going to choose H2 here and make sure that the connection type is in memory, meaning that IntelliJ will boot up, it's a big word, open up an H2 database in memory, so it doesn't live in any files anywhere, it just, lives inside my IntelliJ process. I can connect to it, try out my SQL statements and see if they essentially work, right? And IntelliJ even opened up a console for me here now where I can write these statements. Okay, so what I want to do is schema SQL back here. What I want to do is, I want to create a table. We want to store photos and videos, and an abstract name for that for now is just media. And make sure to put the semicolon here. It could be that at some point our media table is going to explode with 400 columns. For now, we're going to start easy, meaning we're going to start with an ID column. We're going to start with a file name column, storing, just the file name, not the full path, C, users, marker, whatever, just the file name. We definitely want to store the hash that we, generated after, scanning in the files and, converting them to thumbnails. And I also want to store the photos creation date for now, which at the moment could be, the file creation date. It should really be, coming from the image's metadata when the image was taken. But for now, we're fine with these 4 columns. We're only missing the types. That's why I'm gonna paste in this nice line here, int generated by default as identity primary key. If you're unsure what the generated by default blah blah means, please look it up, Google it. I'm not gonna explain it here. Other than that, it's just an int primary key, which is gonna be a sequential number. We can talk about UUIDs and all that stuff in, future episodes. The file name is going to be, for now, just a varchar 255. It's also going to be not null. The hash is going to be a varchar 64 because I think, if I'm not mistaken, we'll need to double check. The Blake 3 hashes are 64 bytes, so we're going to go with varchar 64. And the creation date is going to be a timestamp, but by default, H2 actually puts fractions of a second also in the timestamp, which we don't want, up to, 3 or 6 fractions of a second. And the 0 here means no fractional seconds. And that's why we put it here. Right. This is our table. We don't care about indices for now. We'll just, cover those later in a different episode. I just want to see if this statement works. So Alt-Enter, I run the query in the console. I have, this one session open. And yay, that looks like it completed successfully. By the way, let me try and run this again. Oh no, table media already exists. That's right. What we're going to do is we're going to fix this by saying create table if not exists, and then rerun it. And then we're good to go again, just in case this statement is going to be executed multiple times, wink, wink, in the future. Now we have the table, but I also would like to insert some data just to see it work once. So what I'm going to do is insert into media, right? Then I'm going to go with, file name hash creation date. That sounds good. Values. So we have a file.jpg. We have a hash, which is going to be 12345. We have a timestamp, so 2020 0202 10 10 10. That should hopefully work. Let's try it out. And yes, you can see one row affected. That looks good. I still don't trust the console here. So select star from media. And oh, that was too quick. Select star from, right? Let's quickly do it. Yay, we have our file.jpg row in the database. so everything works as expected. Just make sure to clean up, those statements here. That was just some manual testing. But for now, our media table looks good to go. Everything works as expected. Cool. All right, it's time to finally write some code. I almost forgot what we wanted to do. We have our save method here, a skeleton method where we want to fire our SQL statements from. In order to do that, we need a data source because in Java speak, a data source gives us connections to a database. And I'm just going to paste in some boring code in here, which I have prepared. It's creating a Hikari data source. You would find those lines on the Hikari homepage. I just wanted to spare you that. What you can see is everything is red. That's right, because I haven't loaded my Maven changes. I added the dependencies to the POM.xml file earlier, but I didn't click this icon. Hence, IntelliJ didn't actually, refresh my dependencies. Now it did, and I just need to get the imports right. Right, import Hikari data source and Hikari config. Forget those lines. I'll just explain you what the most important line here does, the JDBC URL. Meaning we're going to open up an H2 database. It's going to live in a file, and the file lives in my current folder, meaning it's going to pop up here. And it's going to be called something media. Now the DB close delay, forget about the parameter for now. You can look it up as an exercise on the H2 homepage. What is important, however, is this init run script parameter, because we can tell the H2 database to execute a Schema SQL file, our Schema SQL file that lives on the class path, so under source man resources. The interesting thing is frameworks like Spring Boot, for example, they abstracted away this functionality so that it works with every database or independent of the database. But just with plain H2 out of the box can also execute these Schema SQL statements. Now, just one tiny thing, if you paid attention, in our Schema SQL file, what we did is we said create table if not exists. And I mentioned it could be that someone tries to, run this file multiple times. That's right, because in a data source, or rather in a connection pool, there might be 10 connections by default. And all the connections by default, they now will run this Schema SQL file. So you will get the clashes just booting up the application, and hence we put the if not exists inside here to work around this problem. But now we have the data source. We should actually be fine. Username, password, Marco is fine. It's completely made up. And we're good to go. That means we can write our first SQL statements. Okay, so I pasted some more boilerplate code, JDBC boilerplate code, into the save method. That is a problem that JDBC has. It's quite wordy, so to speak, so you need to get a connection. And by the way, I shouldn't, call the data source method here. Rather, let's, have a field, right? So we only created data source once. We have it here, and then we get a database connection from the connection pool. Then we create a prepared statement where we say incident to media, file name, hash creation date with a couple of placeholders. And then we put in a string, file name string, a hash, right, and our creation date. And we have yet to figure out where these fields come from. Now with Hibernate, this would actually be a lot simpler, given we had, the annotation mapping and whatsoever. And then we could just, call save on Hibernate Session Factory or the entity manager rather. But for now, this will do just fine. Now, let's think about where we can get the values from. So the file name is going to be rather simple. The file name is going to be image, get file name to string, right? That should just give us, the file name of the image. Now, what do we do with the hash? The problem being that, when I look at the save method, it needs the hash. When I go up here where, save is called inside my for each loop, I can see there's no hash available. In fact, when I step into the create thumbnail method, there's the get thumbnail path method, and inside here, the hash is being generated. Now I'm going to use, I'm going to make use of a maneuver. You heard it here first, which I call, two-way push-pull variable movement. What a crazy name. Let me show you what that means. So I know, I need a hash here. So meaning I'm going to change my method. I know how it needs a hash parameter. I'm going to give it a default variable or default value rather called hash with a spelling mistake. I'll show why that is in a second. Because now IntelliJ will just, add this new parameter here, and I get a compile error just to see, what changed. Not that, accidentally there's, another hash variable somewhere in scope. So I need to fix this now. Where do we get the hash? We just, pull up this information that we need, the hash parameter. But at the moment, the hash is still hidden inside the get thumbnail path. I can actually move this creation out and say, hey, suddenly it's going to happen up here somewhere before we create the thumbnail. And then I'm just going to push down that variable. I'm just going to add it here. IntelliJ tells me, hey, what should I do now? Yeah, let's just add, the hash as second parameter to the method. Then again, I'm going to push down the parameter. Let's just put it there as well to the get thumbnail path method. My keyboard doesn't work anymore. I'm just going to add the hash here. And then suddenly, my method compiles again, right? And I can even get rid of, the image, which I'm going to do just now. So now I just need the hash, and that should pretty much work. Now there should be one last compile error. Again, that's my hash with a double H. I'll just add the hash here, and our maneuver is finished. We extracted the hash. We're good to go. Now, last but not least, the creation date. And here, again, I'm going to take a quick shortcut because I'll just paste in the method, which I think, I took from my own blog article about, getting a file's creation date. Effectively, we're just, reading in the file's basic file attributes, and these attributes have a creation time. And then, we just create the Java local date time out of it. It's just a quick shortcut. Again, later on, we actually need to extract that, creation time from the photos metadata. And I can already see that all my images will have the same date, once we boot up the application. But I'll just go with that now. So I'll just call creation time image here, and we should be good to go. That actually looks pretty good. There's just one tiny last thing I want to do. It's an optimization. We are now, every time, we run our program, we just, save the image data to a database table. There will be duplicates. And there's many actually ways to solve this. For now, I want to use the most naive way. And that is before we save the image, we do a check if the image already exists. So I don't know yet what goes inside the exists method, but, I'm just going to write it out like so. Only if the image doesn't exist, then we want to save the metadata. And I'll just quickly, create this method here and then think about what it should look like. Again, I wanted to spare you all that boilerplate because, again, we tried to get a connection from the connection pool. We create a prepared statement. We simply select one from media where file name equals and hash equals, right? That's the combination we're looking for. We're ignoring, as I said before, indices and whatever have we have to optimize this. But for now, in-memory database, that will work just fine for this proof of concept. We're going to set the string, the file name, we're going to set the hash, and then we simply, if we get one back from the query, then the file exists. Otherwise, we get an empty result set back, and we just return false. Now, before we run this, let me just quickly double check the logic once more. In our for loop, we create the image hash, we create the thumbnail, and if that was successful, then, oh no, that isn't quite right. Actually, what we need to do is we need to get the hash. And then only if no thumbnail exists in a database, then we want to create it and do the rest, right? Like so. So let me just quickly see. That looks a bit better now. Okay, shall we give this a go? Let me try and run this again against a folder on my PC. All right, this looks like it worked because my program says converted 81 images to thumbnails, took roughly 9 seconds. Now the question is, how can we see this? We earlier added an in-memory database here in our tool window, which just lives inside IntelliJ IDEA, so to speak. We actually want to connect to our file-based database. That's right, there should be, yes, there's a media.db file. That's our database, that's our full database. How can we connect to it? Well, simple, we just go inside our app class, we have a look at our JDBC URL. I'm just going to copy this part here, right? JDBC media. I'm going to add a new data source from URL. IntelliJ IDEA already pastes in what it found in my clipboard. I'm going to hit OK. You can see the path is set to my current directory, my working directory, MediaDB. I'm just going to try out the connection. No wrong username password. That's right, because username password is Marco, if I remember correctly. Let's try that again. Testing connection. Yay, that seemed to have worked. Now we have a new database here. Let's refresh our schema. Yes, here is my one table, my media table. I'm double clicking it. How cool is that? I can see hopefully 81 rows. That's right. I can see the file names. I can see the hashes. Unfortunately, I can see that the creation dates are essentially the same because it looks like I copied all these files into a folder on the same day. We'll have to take care of that, but now that is pretty cool, meaning that we just inserted stuff into a database. Oh, by the way, let me just quickly disconnect from my database and rerun my application. Let's see if it still creates thumbnails. It actually shouldn't. Yay, it converted 0 images. It took just 1 second. Okay, so we have that part set up. We scan in the thumbnails, we save the information into a database table. Now it's time to finally render all of that into a nice HTML page where I can effectively see all my thumbnails. All right, we're almost done. Almost. There's just one tiny final puzzle piece missing. And that is converting the information we just saved to a database to an HTML file. And we don't have, a full-blown web application framework there, which, allows us to spin up a server and, serve HTML pages. Instead, we're going to do the poor man's version of that, writing out an HTML file after, converting the thumbnails. And actually, the code is going to be so dirty, you're going to like it. You're going to love it even. Because I don't want to use, a crazy templating language now. What I want to do instead is I'm going to go up here and paste in my HTML template that we're going to be using. It's a nice, string text block. Simple template, by the way, always, feel free to inject the language HTML for easier reading, auto completion, code suggestions, whatever. And what you can see is it's a simple, HTML page, and it has an empty body almost with just a headline, pictures, and then we need, a ton of picture tags, image tags rather, put in here. And these image tags obviously come from a database select. Now things are gonna get ugly fast, hence I prepared some code I'm just gonna paste in here. And I'll walk you through this code because the write HTML file function will be, basically split into 2 parts. And the first part is we need to get all the images from the database. What we want to do is we want to order them, by the creation date descending, so we get the, the newest pictures on top. And then in fact, I would also like to group these images by date so that I have a specific date. And then I get the 10, images associated with that specific date, which is quite cumbersome to do with the plain JDBC API. And it would be so much simpler to do with, a full-blown OM. But that's what we have to work with for now. So I get a database connection. I prepare a statement. As I just mentioned, I want to select all the hashes we have in the database. I want to select all the creation dates, cast to a date, right? Dropping hours, minutes, and seconds, and ordered descending by creation date. I get the result set back here in plain JavaSpeak, and I iterate through all the rows in the result set. And what I do is I get the hash from every row and I get the creation date from every row. And now I have to do something with that. What specifically do I have to do with it? Well, let's say the simplest way that I could imagine is to have some sort of a map where I say, well, the key are the local dates. And then I have a list of strings, the hashes. And that is my, let's call my images for now. And it's going to be a new tree map, by the way, so that it keeps the order. Not a new tree, but a new tree map. Now down here, what I will do is, I'll just say that if there is no list yet, no list of hashes inside my images map for a specific key, then I'll just put it there. So we're just going to say new array list here, like so. And then I'll get, the list for a specific creation date. And I'll just add, my hash here. That's a bit ugly, but it will actually do the job. It will, fill the list with, grouped images by their specific creation date. Now, let me just quickly sketch out the rest of this function. Essentially, the first step is, getting all the data from the database. The second step is turning all of this into an HTML fragment, right? So in fact, we're gonna, do a for each loop over all of our date hash combinations. And we need to, create the HTML here inside that for loop. We'll find out how that works in a second. And once we have the HTML, we actually want to take our template up here, that we put in here, replace this pics placeholder inside the template, and write everything finally to a file. Again, I'm just going to quickly put the code here because it's a bit boring to write. Files write. I just put it into our working directory, output HTML file. I'm going to call template.replace. I'm going to replace the pics placeholder with something. Now the question is, what is the something? Let me just rewrite that to HTML. And HTML is going to be a good old string builder, right? So inside that for loop, what we actually have to do is, now with all the data we have to create a crazy HTML through a string builder. And let me just, add this exception to the method signature. This is it. Now the final part. All right, so let's quickly think how we could, write the HTML, and we're gonna use the lowest level of HTML writing possible. Just, using strings. So for every date that we get, what we want to do is we just want to append an H2 tag. Then we want to append the date we get from the database. And then we want to close this H2 tag again, right? That looks pretty cool, doesn't it? And then we have a nested loop because we need to travel through all the hashes, right? And we also need to do something for every hash. What we're going to do for every hash, though, is going to be quite interesting. So we're going to do an HTML append, right? It's going to be an image tag, and the width of this image tag hard-coded to 300. That's the size, we convert the thumbnails to. Again, this all needs to be fixed in the future, but for now, I just want to see, as always, I want to see it work. I'm going to close down the source tag here as well. I also want to add the loading equals lazy attribute, so the browser doesn't request all the images on the page, but it does them, one by one, once you scroll down. And then we just, close the image tag, whatever have you here. Now the question is, how can we fill in, this source attribute? And here what we're going to do is we're going to go to our thumbnails directory. We have that. We know we have the hash, and we store, our files, our images by convention. The convention is, first of all, that the first two characters of the hash are a subdirectory. So we resolve that subdirectory. And yes, we can clean this up later on. And then the file name of the image is actually the hash substring starting from character 2. And then, by the way, what else are we missing? I think at the end of the day, right, .webp. We're storing everything in WebP format. So this is the path to our image. Now, the only thing that's missing is we're going to call .append image to absolute path, right? Just in case, not to absolute path, but image to absolute path to string. We don't even need that here. It's redundant. And, because our HTML page is completely unstyled, what we also do is after, every group of images, after every date, we're just going to render a breakline tag. Now, I actually don't know at the moment if this is going to work, but what I'm going to do is I'm just going to rerun my application. It didn't convert any images because the data is already in a database, but it should have written out the file. There's an output HTML file, right? As you can see, there's, a couple of tags here in one long line, right? That is pretty cool. Don't open up this file, by the way, now through IntelliJ, because what IntelliJ does is it always serves these files through a web server running on localhost some port number. And that's why you can see all these broken images here, because we cannot, reference local files that way. What we actually have to do is you have to open up Explorer and then open up the file here. And then, yay, we can see pictures. Look at that. Well, hopefully you can't see these pictures because this is, all stuff from my family and I want to keep them out of YouTube. But you can see that we effectively have, for one specific date, because they're all taken on the same, they all have the same, file created attribute. We can see the pictures. The width is 300. They all get rendered next to each other. And that, by the way, is pretty damn cool because that means everything is working as expected. Yay! Wow, that was a lot to digest. I'll tell you what, before we turn this now into a full-blown real web application, quite likely a Spring Boot application, I want to fix the image grouping. Because as you saw earlier, is that every image was supposedly taken on the same date, which isn't true. But for that, we'd have to, read the real image creation date from the image's metadata, which is a huge can of worms. Different manufacturers, different image types, whatever. We'll have a look at that in the next episode. And then we can think about, all the outstanding, 20 million still bugs and feature requests, whatever have you. That's it for today. I hope you enjoyed it. Sayonara.